Alright, Algebra 2, so one thing that I recommend is watching the percent decrease video before watching the percent increase video, because I think that one I went a tiny bit more in depth. This one I'm going to go in depth in maybe a different way, so maybe after both these videos you'll have a better understanding of how to write problems that are either decreasing or increasing. Alright, so if you notice in this problem, let's say you bought a signed Russell Wilson jersey for $100 in 2013. Every year the value of the jersey is going to increase by 12%. How much will the jersey be worth after, let's say, 2 years? We'll just stick to 2 years. So the other jersey, it was a situation where the value of a jersey was going down a bit. Now we're going to look at a situation where the jersey is increasing, right? Russell Wilson is getting more popular every year, so every year the value of the jersey is going to increase by 12% every year. So if we want to find out, let's just use the very same method that we did the last couple times. Is if you want to find out how much the Russell Wilson jersey will be worth in 2 years, well, let's find out how much it's going to be worth after 1 year. So we start with 100. Let me go ahead, and I made a minor mistake. Hold on. Here we go. All right. Let's say we know that it's increasing by 12% every year. So we have 12%. All right. Well, let's turn that to a decimal. That's 12% divided by 100% is 0.12. All right. Now we want to find out how much the jersey is going to be worth after the first year. So we're going to get 100 times 0.12. So 100 times 0.12. And we get $12. Alright, so we know that after the first year it's going to increase by $12, so we're going to get 100 plus 12, and then we know that the jersey is going to be worth $112 after the first year. Well, now let's find out how much it's going to be worth for the second year. So after the first year it's worth $112, so the next year we're going to get $112 times 0.12, because it's increasing by 12% every year. So $112 times 0.12 is 13.44. So now the jersey is worth even more the second year, right? Because he's getting more popular. So we're going to get 112 plus 13.44 cents, and we're going to get this should add up to approximately 125. Oops, that looks like a 6. 125.44 cents. All right. So that's how much the jersey is going to be worth after the second year. All right. Well, let's try to talk to each other about how can we find a way to maybe find a shortcut in doing this. And this is, again, where exponential functions come into play. Because what if I ask you how much a jersey will be worth after, I don't know, let's say 25 years? Having to repeat this entire process can get a little bit time consuming. So we want to kind of find a way to go about it. All right, so we know one thing that we could do is we know for a fact that if we want to write an equation, let's say y is equal to, I'll use a different color. Let's say we have our exponential equation a times b to the x. Alright, so let's just go ahead. We know a is our starting value, which we know that to be 100. Now b is going to be the percentage we keep. Alright. So we know for a fact that we are going to keep, no matter what, we're going to keep 100% of its value. We're going to keep the $100 in the bank, right? No matter what. So we're going to keep 100% of its value. And we're going to increase every year by 12%. This comes out to 112%. If we turn that to a decimal, we divide by 100, and we're going to get that this equals 1.12. Now this is our constant multiplier. And remember, it's the percentage we keep, so we're keeping 112%. We turn that to a decimal, so now we're going to get y is equal to 100 times 1.12 raised to the x. Alright, x represents time. Now if you wanted to, we could just, like before, 100 times 1.12 raised to the first power is going to be $112. You can even do it with yourself, and you'll see that this is true. We're going to get here is 100 times 1.12 to the second power, and we're going to get the $125.44. Okay? So this is a way that we could write it using exponential equations. Again, the A is our starting value, and the B is the percentage we keep. Well, we're keeping 100% of its value plus 12% of its value. All right? All right, well, if we look over here, now I'm going to come up here so that you can see this. We have 100 plus 12. We can rewrite this problem. All right, so we have 100 plus 12, and we get the $112. So if you notice, one thing that we can do is we have 100. I'm going to use a different color actually. Let's go ahead and use purple. We have 100. Right, so the 100 is this right here. All right, because we're starting off with 100, and then we're going to get plus 100 times 0.12. So if you notice, 100 times 0.12, that's just the 12. That's where the 12 comes from, right? All right, so one thing that I want to show you is if you look here, I'm basically going to go backwards, and at first it's going to seem a little weird, but you're going to understand what I'm doing here. 1 plus 0.12. This right here, I'm rewriting it as 100 times parentheses 1 plus 1.2. Now to show you that this makes sense, I'll go ahead and just redistribute it. 100 times 1 is 100 plus 100 times 0.12, so we get 100 times 0.12. Alright, so you see here, this is the exact same thing that we have right up here. Let me go ahead and erase it. That's just for you to see. Alright, I'm just getting fancy with it, but we know 1 plus 1.2 is 100 plus 1.12, right? 1 plus 0.12 is the same as 1.112. So 100 times 1.112 is the $112. So if you look down below, this 1.112 is exactly what we got over here because we did 100 plus the 12%. But even if we look over here, it's the exact same thing that we did right over here. 100 times 0.12 to get the $12. And then we're going to get $100 from what the jersey started with, plus the $12 that it's going to gain after the first year to get $112. That's just the same thing. It's the exact same thing, even mathematically over here. 100 plus 100 times 0.12 is the same thing as 100 times 1 plus 1.2. All I did was just basically undistribute. I took the 100 out of each term here. And we kind of see that it makes sense because we could have went ahead and distributed and we would have just get back to up here, but we didn't because I wanted to show you that 1 plus 112 is the exact same thing right below here. Alright, so hopefully that helps. Once again, when you're dealing with problems that increases, you just do you're having 100% of its value plus 12% of the value you keep, and then that gives you your constant multiplier. Divide by 100, and then you put it into your equation with starting value, and you get this right here. Alright, hopefully this helps to clear that up.